Hi, and welcome back to my channel. This is Paula with Automated Dynamics, and I've got a snap signal condition monitoring demo that I put together. And so the purpose of this video today is going to be to, one, show you what I put together, and then number two, show you how to do the register mapping, because that can be a little bit confusing. There's a lot of addressing, and so you kind of have to keep up with that. And then three, to show you how I put this dashboard together on the Red Lion HMI. So I will have chapters here down below, so make sure you fast forward if you need to, and let's get into the video. So first of all, this is a condition monitoring dashboard. So at first glance, you see whether maybe a motor is good or bad. And so here we have a condition where one motor is bad. We don't know exactly what's going on. But if I click on here, it'll give me a lot of data points here. So I have some data that's being logged. I've got some trend charts. I can click on these and I can see, go in there and see a little bit more of what's going on. I have a temperature gauge here, which seems to be what is going on here. This is the temperature alarm. If we look at that gauge, it's in the red section, so that's been triggered. I can also set the thresholds of the alarms so that I can monitor exactly the points where I needed to give me an alarm. And if I go back here, if I go to the settings of the current transformer that's attached, I can also see what all is in there, and I can change values if I need to, set points, the interval time. That snap signal CT converter is very cool. It's got a lot of neat features. I've got a data sheet here of some of the pictures inside the data sheet in case you are interested. If I go back now, you'll notice I'm logging, or at least I'm monitoring the X and the Z RMS velocity, the current, and the temperature. This usually tends to be what people want to look at when it comes to monitoring vibration and critical assets like that. So if I go back here, this motor icon will turn green or red depending on the condition, and that's pretty much it. Here I can look at exactly the values that are being logged. If I go back to my main section, these are grayed out because I don't have anything connected to those motors yet, but it's the same deal here with my motor 2 dashboard. If I click on my demo info button here, it'll take me to this layout where I have made a type of graphic here to give you an idea of how everything is connected. So let's start with the lowest level here, which is the IO link. I've got a tower light that's also letting me know if there's any kind of bad alarm, and that's actually being connected over through IO link. So the IO link then outputs to Modbus RTU on port 4. And then on port 3, I have that S15C CT converter sensor addressed at Modbus ID 1 connected to port 3. So you see how that can be a little bit confusing. You know, you have to keep track of stuff. And then on port 2 of my Modbus snap signal controller, I've got vibration sensor with ID number 10, and on port 1, vibration sensor with ID number 8. So all of these are Modbus devices, and they're going to be outputting Modbus TCP to my Red Lion HMI, which in itself is the overall master of everything. It's getting all the data, it's logging it, it's creating alarms, it's giving me this nice dashboard, and it's managing a lot of these things. It's writing some logic in the background, so I do want to show that to you. All of this is on my 192.168.0.x IP address subnet. So now you know what's going on. Let's get into where the register mapping needs to be done in the DXM R90-X1. Okay, so first of all, you're going to need to download the DXM configuration software. Make sure you do have the latest version, which is version 4.16.2. And once you have that going, make sure you have the DXM R90-X1 selected and go ahead and click Connect. So I've already got this whole thing done, this XML, which if you are interested in looking at, you can send me a request. I'll put my information on the description box below. So let's just get into the first thing. Number one, register mapping. So let's run through some of these settings. So you're going to be in the RTU tab because everything we're doing right now is RTU, Modbus RTU. So you'll notice port 1, 2, 3, and 4, the default baud rate is 19200, which is perfect. All of this has to match. You have to leave all of this. All your devices have to be 19200, you know. So if you change this to another baud rate, you have to change that on that device that's connected to that port. So make sure you go ahead and do that. On my read rules, you'll notice that I have all of my read rules for my Modbus device. These numbers, the 5201, that's the actual Modbus holding registers, and all of that is found in the data sheet. So you can look that up and create just a single read rule where you bring in all of the data points. And I just gave it a quick, you know, I don't have everything named specifically, but and then I put them all into a local register inside of the R90X1. On these vibration sensors, you'll notice you have to tell it what port number you're connected to. I've tried to label everything as much as I can just so I can keep track of that. The server ID now, you'll notice a little bit different language now in the DXM software. This used to be slave ID. It's now called server ID, and it just means the Modbus device ID number. The default on the banner products, the banner Modbus devices, is usually going to be a default of 1. These have been changed because I used to use them for something else and whatever, I didn't want to change them, so they're staying at 8 and 10 here. There's a total of 22 Modbus registers that I want to look at in those Modbus devices. Notice I do have to designate what port number everything is connected to. So same deal here, you know, you don't want to overlap on your local registers. When you create these local registers, you're creating a memory map, and so you want to, these are arbitrary values. I've made several videos on register mapping if you want to go and look at that. I'm just going to give you here this overview. You can take a snip, a screen capture of this if you have any more questions. Banner Engineering is really good about listing all of these Modbus registers on their data sheets, so make sure and go and take a look at that. One quick note on these, so if your Modbus holding register is a writable one, you do have to, like if you're turning on an output like a light, or you're writing to the COM settings of the CT, for example, or the parameters, maybe you have to set a min and a max value there, or you want to change it, you do have to write those values into the device, but you also have to create those same registers. You need to create read rules for them. So even if they're writable, you set it to be writable with a write rule, you're not going to be able to read what's in there. So you have to go in and do a read rule for those as well. So I've already done all of this. I've already labeled everything here. It's pretty straightforward. And then you can use your local register, your register view page here to gather some data. So if I do a quick read, maybe let's start with register 1, and this one I think can do up to 20 or 40. And so I've got data here. I'm not scaling anything. All my scaling and logic and alarms, all of that is going to be in the Red Lion program. So this is kind of a quick view of everything that I did in this side of the software to get it to read and write holding registers over to my Red Lion HMI. Now, what can be confusing for some people is that they might think that these holding register numbers 1501, that's what you're going to put on the Red Lion site, and that's not true. Whatever you copy onto for the local registers, your local registers are going to be what you are going to reference in your Crimson program. So hopefully that makes sense, and that concludes this part of the video. I will have some reference links on my description box if you want to go into how to address some of the converters, some of the Modbus devices. If you want to learn how to do register mapping, that's going to be linked down below as well. So let's move on to the Crimson software. Okay, so I do have a CR3000-07000 HMI, and so I have created this already. I'm just going to show you how I set it up. I love the fact that Crimson kind of gives you an order, like how to create your program. You start off setting the communications, then you create your tags, and then you create your display pages, and then you run the programs, and there's some extra stuff here that we're actually going to look at. So for my communications, I did say the HMI is going to be the Modbus master. In this case, we do have to give it a IP address. I'm connected to Ethernet 1, and I do want to make sure that if I want to download directly to it over Ethernet, then I need to select manual and set that IP address there. I do like to keep things labeled as much as I can. If I go here to protocol 1, you select the driver, go down to Modbus, and I am using the TCP/IP master. And I did label that as what I am connected to, which is a DXM or 90X1. The IP address of that Modbus Snap Signal controller is 0.1. I did not change anything else. All of this here is the regular default settings that come with the Modbus driver. So that's actually done now. That's done, and so now I can move over to my data tags. So I do create folders, try to keep everything pretty tidy here. Here's all my vibration and temperature data tags. I have sourced them directly from my R90X1. I've allocated that local register to it. And some of these values are going to be large values, inches per second, that kind of information. So I am doing all of this scaling in here. So what is really nice about Crimson is that it'll allow me to bring in that data, which it's Modbus, so holding register goes, a regular 16-bit holding register will have a range of data from 0 to 65535. So, but the Crimson program will take care of displaying that in the scaled form that I tell it. So I want it to go from 0 to 6.5535, and this information is also found in the data sheet. So on my formatting here, that is just set to general, and that's all I have for my vibration sensors. For my CT sensors, I've also brought in I've done some of the same stuff here, but I have created a few multi-state tags, and I really like this feature of Crimson because it really just simplifies some of the things that are in this program. So for example, there's a setting where I can write to the converter and tell it I want it to run on a 60 hertz or a 50 hertz line frequency. And so using a multi-state and setting it to however many states, I can tell it exactly, a value of 1 means 60 hertz and a value of 2 means 50 hertz. So what I will see on my HMI is that value. So for example, if I go here to my program and I go to my motor 1 and I look at my settings for my CT, and that particular tag is right here. So if I click on that part, it will allow me to toggle between 50 and 60 hertz. So that's really cool. It makes it just really simple for me and the user to know what's going on. Another example of a multi-state was the CT amp value input. So this is a value that I can tell it what CT am I connected to. Is it the 20, the 150, or the 600 amp? And so depending on the value, which by the way is also found in the data sheet, 20, we have one of 20, we have one of 150, we have one of 600, and so I'm displaying that accordingly. So that also just makes it really nice. And if I now go to my IO link, the IO link is kind of interesting. There's a couple of holding registers I need to be made aware. This is a simple tower light. So I'm bringing in, it's just a 16-bit, and I'm turning on red, yellow, green. And so the holding register for that, I made it 101 in my local registers in my DXM. But I do want to make you aware that if you're working with some of these values, you do have to tell it with the process data out. You do have to tell it that I think you have to enable it, and that's how I've understood this value to be. So in my program, I have made it to where the program will tell it, when it's writing a green light to my tower light, I'm enabling at the same time that port to do IO link out. So just kind of a quick note, I was wondering why my lights weren't turning on. That's because I wasn't enabling that port to do that. So that was kind of a little gotcha that I had to work around. And then motor 1 alarms here. I have 2 motors, 2 vibration sensors that I'm working with, and this is all my set points. These are the values that I'm going to input into the HMI that I'm going to tell it. This is my baseline kind of, you know, this is the high alarm, this is the max. So I have made those to be retentive so that when I power cycle my HMI, it's going to remember those values. These are formatted as general. I do have min and max limits there. And I have some alarms here going on too, and these are, notice these are blue in color, so these are internal tags. I'm mostly using these with my program that I'm running down here, and I'll just get to that here in a little bit. Same with my motor 2, and then I've created more alarms here. On my display pages, I've got quite a bit of stuff going on. I've tried to make it as nice as possible. I've got these mounted so that you will only see one at a time, and so depending on whether this condition is true, so if my motor 2 any alarm is on, it's going to make sure that the red is going to be visible. So that, I really like that feature. Same with the green. Once I created my alarms, if it's a good status, it's going to show this motor icon in green. So I really like that, and the gray just means nothing's connected. Same with my motor 1. All of these are all stacked together, so that makes it really, really nice. You can add pictures here. So I have this data sheet button going to my pictures of the CT data sheet, and I really like that too. We actually have a system primitive, I believe, that you can actually insert with your, if you have an SD card, you can insert a PDF, so you can actually put in a whole data sheet in here. I did not want to go through that. I just didn't have time to do that. But here's my dashboard, and I really wanted to show you, I think this gauge is kind of cool. If I go on it, and there's a lot of gauges that you can pick from. You can do multiple bands on here. So like when I tell it that I want this high temp alarm, this is my high temp setting. That will be my red field, and then my green is whatever is below that. So I really like how that is enabled, and it just makes it like look really clean and nice. I have the same deal going on here with my lettering here. I can make those be shown visibly only when the alarm or good condition is enabled. So that's pretty much the gist of all of that. My buddy Joe Wazoo has an incredible channel where he walks through setting up all of this, and he has an awesome channel, so go check him out. Shout out to him, or take one of our HMI classes where you spend a whole day and you create dashboards kind of like this as well. You go through alarms and Webserver and creating trend charts and all of that. So just a quick note here also on my programs, I've set up my motor alarms. This is very simple if else logic. So this is kind of how I have done it. There are multiple ways to skin the cat, and I'm sure there might be quicker ways to do this, but this is just kind of a simple way of doing all of that. Same with my motor 2, and then this is where my my any error and my alarm status logic is found. So this is here where I'm turning on the tower light to a green, and I'm giving it the command to go to enable that port. This is very important right here. If I don't have this written on here, it just won't turn on. So just a note about that. And these are my OR statements. So if any of these alarms are on or true, it's going to trigger my any error alarm. And then that's going to trigger my tower light to turn on to red, which is that 16 value. That's the numerical decimal value to give it the red light. And my good status alarm is going to turn to 0. Else, all the opposite. So I've done that now for my motor 1, motor 2, and then my any error alarm. And then I do have a startup script running, so like when you start this from the very beginning, I have some values that are pre-programmed in there. You can always change these, but otherwise they're going to be 0 when you start it up, and I don't like that. So once you create your programs, it's really cool. You can click this little translate, it's actually our compile button, and you can go to display pages, click on this guy up here, and then you can call those programs to run. Otherwise they will not run. And then on your web server, moving on, you just enable that web server. I like to have it without all the restrictions, so I keep it at HTTP. And under my features, you have to enable the remote control, the remote viewing. And then me and Joe, we do like to use the bare display scaled, because as you can see, when I max and minimize my views here, the scaling stays the same. So I think that's really cool. So I like that feature. And on the data logger, so what I have done, so for example, my motor 1 vibration data, I have brought in 0.1 and 0.5, which is my X and my Z RMS values. And then I've brought in my X and my Z max values, which I have set for my threshold setting. So that's what you're going to get out of the vibration trend chart. On my temperature, you're just going to see the temp high setting that we set, and then data point 3 is the temperature. Current, very similar, and then motor 2 and motor 2 V and T. So that's pretty much it. I hope this was helpful. If you have any questions or you want to get a copy of these programs, you are more than welcome to request them at my email, ppaz@adcreps.com, or just contact me, reach out to me on LinkedIn. And I hope this was helpful. Catch you in the next video.